Hi guys, so today I'm doing the USACO 2019 February contest, Bronze Division, and this is the first problem, sleepy cow herding. So you can pause the video and read through the question. I'm just going to run through it quickly. So basically there are three cows. You can imagine they're on a number line and they all have different X positions, right? And Farmer John wants to herd them and get them right next to each other in consecutive locations. The example they give us is position 6, 7, and 8. But because the cows are sleepy, Farmer John can only move the cows if they are at an endpoint, and he can only move one at a time. So this tends to move the cows closer and closer together because the endpoints get smaller and smaller. And they're basically asking to print out the minimum number of moves possible and the maximum number of moves. So let's just look at the sample input. So here the cows are at position 4, 7, and 9. Right, so let's just draw that out real quick. So positions 4, 7, and 9, I'll just make a number line. So here's 9. 1, 2, 3, 4, 7, and 9. Right, so they're asking for the minimum and the maximum moves. Well, if we look at the minimum moves, I'll say red is min. If we just take this cow, which is at an endpoint, and we move it here, then we have all three cows herded, and we're done. But maximum number of moves, we can take this cow, which is at an endpoint, move it here, and then take this cow and move it here. So now we have the three cows over here, right? So that would be our maximum number of moves, which is 2. So if we were to be given any random 3 points, how could we know where is the min number of moves and where is the maximum number of moves? Well, let's just account for one thing, right? We could be given a consecutive position of cows already, right? So that would be 0. What if it looked something like this? Well, then we can only do one move, right? The only cows we can move are this one and this one, and they both can only go here. So that would only be one move. It seems like what is deciding the number of moves we have is the gaps between the cows. Because let's say for our max moves, right? We had a cow that was like all the way over here. How would we decide what our max moves is? Well, what we would do is take our endpoints, like this one, and we want to keep our endpoints as far away as possible while moving them in order to get the maximum distance and the max moves. So we move this one here, and then we will move like this one here, this one here, this one here. So it seems like our max moves is just the biggest gap between any of the two cows. In this case, 4. Alright, so we know how to get, you can test this out with many examples. That's how I did it. With many of these bronze problems, just look at it and try to find a pattern. And for the minimum number of moves, well, it could either be 0, right? Like we saw if there were 3 consecutive cows, or it could be 1 if the cows look something like this. So this is a minimum of 1, also a maximum of 1. And then could we have a minimum of 2 moves? Yes, we can. What if it looks something like that? Right, then we would need at least 2 moves because we need to move this one here and then this one here. Can we get a minimum of 3 moves? So what if instead of the gap was 2, the gap was 3? Well, this doesn't really matter because we can just move this cow all the way, we can move this cow all the way here and then just move this one all the way here. So I don't think we can get any minimum number of moves that is more than 2. So that should be all the data we need in order to solve this question. So I'm just going to run through it one more time. So our minimum moves could be 0 if they're all consecutive already, 1 if the gap between the two cows is 1 and the other one is 0, 2 if the gap between two cows is 2, and then anything else is just 2 for the minimum. And then the maximum is just going to be the maximum gap between any two cows. Hope that makes sense. I'm going to code this up. I'm actually going to be using Python for this one because it's fast enough to work. Okay, so this one, sample input, I'm just going to copy this real quick. And alright, I'm just going to start coding it up. Okay, so there we have our inputs, and we can start with our solution. So let me input our data. So it's 3 integers followed, each one separated by a space. So we can split that, and then we'll just map an int to each of those. And the reason I have the list there, because the map, if you map an int to a list, it returns a map object. So we have to return it back to a list. Okay. And then, and just in case our data isn't sorted in a number line, we're just going to sort it. We have enough time anyways, because our solution is going to run really fast. Okay, so let's think back to our solution, right? So first, if the three cows are in consecutive positions, then we just return 0 or print 0. So how do we say that? Well, if the third cow is 2 away from the first cow, and they're sorted, that means that they must be in consecutive positions. So if data 0, right, that would be the first cow plus 2 equals data 2. Then we print 0. This is for the minimum, right? Else if, alright, next, how do we get one minimum move? Well, that means there has to be a gap of 1 between either of the cows. So we could either have the third cow and the second cow, or the second cow and the first cow. So we could do if data 2, data 2 is data 1 plus, plus 2, right? Yeah. Or data 1 is data 0 plus 2. Then we just print 1, and everything else we print 2. Okay, that's everything done for the minimum. And then now we have to do the maximum, and that is just the maximum gap between the cows, any cows. So we can find the max between the second cow and the first cow, and then the distance between the third cow and the first cow, or yeah, second cow, sorry. And because we're finding the distance between them, not like, well, like if you're on a number line, right? If you subtract position 2 from position 0, there's not two cows between them, there's only one cow. So we have to subtract 1 at the end. So let's test this out with our input case. Let's see what the sample output was, 1 and 2. Let's see, yep, we get 1 and 2. So let me just download this as a zip real quick. Download, and now I'll go to files, and what was this called? Herding.out. Herding. Okay. If I can unzip this, please. Oh, there it is. Okay, and then I'm gonna go to the USACO and upload it. Python 3.6.9, choose file, main.py. Alright. Alright, guys. Looks like we did it, and we did it pretty dang fast, considering we are using Python too. So, yeah. Alright, that's it for today, and yeah, I plan on doing the rest of this contest, so stick around.